Today we are going to review for a quiz over sections 7.1 and 7.2. And by the time we're done with this video, you will hopefully be very prepared for this quiz. Alright, let's go ahead and get started with this review. Okay, so let's take a look at this problem. Your job is to tell whether each function shows growth or decay, and then you are to graph it. You do not need your calculator to graph this. I just want you to sketch it. Alright, so first of all, look at this piece right here. If we just look right here, what is this? This is our what? And then what is this? This is our what? Notice I didn't tell you what they were. It's up to you to tell me what they are. If you need to, go back and look at the previous slide to determine what this is and what this is. Look at your notes. What does this do? It tells you what? What does this do? What does it tell you? With that in mind, you're going to, whichever one was the A, you're going to put there. Whichever one is the B, you're going to put there. And then you're going to determine and write it right here, whether it is growth or decay. And which one of these, A or B, tells you if it's growth or decay. It's up to you to determine. Okay, when you're done with that, then I want you to graph it. When you're looking at the graph, make sure you draw the asymptote. Where's the asymptote? Is it here or is it here? Okay, what did I say in the previous slide? You have to determine where the asymptote is. If you don't remember, go back and listen to it again and figure it out. Now, where does it cross the y-axis? Which one of these numbers right here tell you where it crossed the y-axis? Again, you need to determine what it is. If you don't know, go back and listen to the video again and figure that out. Alright, so go ahead and just show a graph. Make sure you draw the asymptote. Make sure you put a dot on where it crosses the y-axis. And then make sure you show whether it's increasing or decreasing. And so draw the graph. Now, when you're done with that, go ahead and do it to the second one as well. Alright. I'm going to stop right there, and I'm going to let you figure this out, and you bring this to class completed. Okay, now let's go on to this slide. This slide is applying what we've just learned. You have a formula, and it's right here. A of t equals A times the quantity 1 plus r raised to the t. Now, notice what I said right here. This piece right here is the final amount after time t. This A value right here is the initial amount. As I said before, it was where it crossed the y-axis. That's how much you start with. That's the number of bacteria in your petri dish when you start the experiment. Your R here, right there, is your growth rate. And of course, t is the amount of time in years that you're performing the experiment. Okay, now, remember, here, very important, if it's 1 plus, remember what we said in class. 1 plus means what? 1 plus your R. That means it's going to be growth. Good. And if it's 1 minus R, what does that mean? Yes, that means it's going to be decay. All right, so with that in mind, let's walk through steps 1 through 5 in this application problem. Now, let's read what it says here. It says the initial amount of $15,000. Okay, what is your A value? A is the initial amount. That means A is going to be what? Yes, that's right. It's going to be $15,000. It increases by 12% each year. That is your growth rate, 12%. Now, we need to change that to a decimal, so 0.12. In how many years will the amount reach 25,000? 25,000 is what the final amount will be after t years. So you're going to plug that 25,000 into for A of t. Okay, so here's what we're going to do. You have your formula right here. Okay, now you're going to take this formula, you're going to plug the A value there, the B value there, the R value there, and then you're going to simplify that so it's 1.12. So here's your formula right there. Now, from here you can take your device. Okay, you can take your, whether it be the Inspire, an 84, or just your device on your smartphone. You're going to punch that in. Just make sure you put these parentheses like it shows right here. So enter it in just like what you see right there. So you go ahead and do that. Now you're going to have to zoom in and out and adjust your axes a little bit, and you can adjust it so that it'll be going out to at least the A value, which means your y-intercept needs to be all the way up to at least 15,000. Preferably, maybe even closer to 25,000. All right, then you're going to trace the graph. Okay, now to trace the graph, remember, if you're on your smartphone, you just touch the curve, and then you can move it right and left along the x-axis, and you'll see that point move. Okay, so anyway, looking at that, I want you to determine where the x value will be, or in this case, it's a t value. So as you move your t along, when you see the y value reach 25,000, stop, and then look at the t value. The t value is the number of years it will take for it to reach 25,000. Okay, and that's all there is to this problem. Okay, let's take a look at this problem. Now, I'm not going to do it for you. You're going to have to be the one to work through it, but I'll give you a little bit of help here. All right, so for starters here, it says an initial amount of 40,000. Initial amount is what? A, B, or R? Okay, you have to decide. If you don't remember, go back and watch the video again and see what it is. 8% per year. What is the 8%? Is that A, B, or R? Okay, you decide again. All right, now, it says, in how many years will the amount reach 60,000? What's 60,000? Is that your A? Is that your B? Is that your R? Or is that your A sub T? You determine what it is. If you don't remember, go back and read it again. Go back and play the video again. All right, so you're going to put your A value at this point right here, the R value right there, and the F of T value right there. And now you're going to approximate it. You're going to approximate it to 60,000. In other words, plug it into your device, and I want you to trace it until you can see where T will be at 60,000. All right, so that's what you are to do. You go ahead and do that and have that all done and ready to go for class tomorrow. All right, folks, now that you completed this assignment, at least to the 7-1, here's what I want you to do. I know you probably thought I wasn't going to give you the answers, but I got thinking. You know what? Might be good if you knew you did it right. Because if you didn't get it right, that way you could go back, watch the video again, and figure it out. Okay, so let's take a look at what these answers are. All right, the first answer, there it is. There's your first blank, second blank, and your graph. All right, number 2 should look like this. Okay, how'd you do? Did you get it right? If not, go back and look at it again. Okay, here's your number 3. There's A, B, C, and D. And then your graph is right here. All right, now, if you understood this well, fabulous. You're ready to go on to number 2, 7-2. If you're not, then I'd like you to go back, play with it again, study it again, because you're going to need to give this back to me on a quiz next class period. So make sure you understand what we just talked about. Okay, now we're going to take a look at 7-2. Now, 7-2 deals with inverses of a function, okay, and also inverses of a relation. Now, first of all, let's talk about what a relation is. This is a relation right here. It's a set of ordered pairs. Now, if I want to invert this, or if I want to find the inverse of this, I simply invert each of these domains and ranges. So, if I want to find the inverse of this relation, and notice this relation is 0, 3, 1, 6, 4, 9, so on and so forth. The inverse of that relation would just be, I'll switch the domain and range. So for the inverse, what was the range is now the domain. So then it's going to be 3, 0, 6, 1, 9, 4, and so on and so forth. It's that easy. So your task on your quiz coming up is I'm going to give you a relation like this. And you're going to plot it, kind of like what we plotted it right down here. Okay? And you're going to be able to tell me what the domain is, see the domain, and what the range is right there. And then after that, I'm going to ask you to find the inverse of it, which means you're going to have to set up a table like this, and you're going to invert it, just like what we did here. And then you're going to tell me the domain of this right here. Well, what's the domain now? Well, it's what the range used to be right here. So you're going to put the new domain being between 3 and 11 inclusively. And then, of course, the range used to be the domain, okay, but for the inverse, it is now the range. And then you're going to show the graph of it. And something I want you to realize. Notice if I draw the line y equals x, and that is the equation of this. Y equals x. That's the equation of that line. Notice that equation, that line, is the reflection line between the function and its inverse. Okay? Do you see this function here has inverted? And its inverse, you see the function and its inverse? Notice it's a reflection over y equals x, just like that. Alright, let's take a look at a couple examples here. So, here's what you see first of all. We see right here, here's your relation. 0, 6, 2, 10, 5, 12, and so on. Now, your job is to tell me what the inverse of that relation. So go ahead and write in the inverse there. And then I want you to tell me what is the domain and what is the range. So go ahead and tell me what those are. And when you're done with that, then I want you to graph it over here. I want you to graph it over here. So go ahead and pause the video and do that. Alright, now that you've graphed the function and you've also found the points of the inverse and written the domain and range, over here I want you to write down the domain and range of this inverse right here. Remember, what was the domain up here becomes the range down here. What was the range down here becomes the domain up here. And then I want you to graph it up there as well. Okay, go ahead and pause it and graph that. Alright, what we've done so far is we looked at how to find the inverse of a relation. Now let's look at how to find the inverse of a function. So let me point some things out for starters here. First of all, let me point this out. Inverse operations undo each other. Okay, like addition, the inverse of that would be subtraction. The inverse of multiplication is division. Okay, so in a similar way, inverse functions undo each other as well. Now, let me talk about the notation of this. You know that the function notation is f of x. Well, the inverse function notation is denoted as f inverse of x. That's how I say that, f inverse of x. All right? So, let's go ahead and take this function. I have f of x equals x plus 8. Well, what's the opposite of adding 8 to x? Well, subtracting 8 to x. So all you're going to do to find the inverse is you're going to go x minus 8, and then you're going to write the f inverse of x there. That's all there is to it. Now notice you can take a value, like for example x equals 1, and you can plug it into the function right here. And 1 plus 8 is 9. Now, take this range value and let's plug it into the inverse function. So we're going to plug it right here. 9 minus 8 is, yes, a 1. Okay, notice it gave me back this. Okay, so by doing that, it's a way of checking to make sure that these functions are inverse functions. Alright, now, let's take a look at another one. Here I have f of x equals 5x. What's the opposite of multiplying by 5? If you said dividing by 5, you are correct. So it's going to be x divided by 5, and then write f inverse of x. So there is our inverse of our function. Alright, it's that simple. Then you can. Now from here, let's go ahead and let me show you another way of finding inverse functions, especially if the function looks a little bit more complicated than just the two of these. Let's say hypothetically that my function looked like this. Let's say that I gave you f of x is equal to, say, How about 2x minus 3? Now, when you're doing it this way, we're going to do this in steps, and I want you to make sure you write down these steps. Okay, so step 1, you're going to replace the f of x with y. Okay, let me write that down. Replace f of x with y. Okay, so let's do that. Y equals 2x minus 3. Step 2, I'm going to interchange x and y. So let's do that. So where y is, I'm going to put x. Where x is, I'm going to put a y. So it's going to be x equals 2y minus 3. All right, step 3. Now I'm going to solve for y. Okay, so let's go ahead and do that. When I solve for y, I have x equals 2y minus 3. I'm solving here, so I'm going to add 3 to both sides. So that gives me x plus a 3 equals a 2y. Now here I have 2 times y, the opposite of timesing by 2, dividing by 2. So we're going to divide on both sides, just like that. And then I will have y is equal to, because these divide out, I have x plus 3 over 2. Now I'm going to use my symmetric property, and that gives me y equals x plus y over 2, so I can flip that around just like that. Alright, so we've solved for y. Now let's go step number 4. Step number 4 is I want to replace y with f inverse of x. So I have f inverse of x is equal to x plus a 3 over a 2. And when I've done that, this is the inverse of my function. Alright, so 2 ways to do it. One is just by looking at it, and you can do that with simple ones. But with others that are a little bit more complicated, use these 4 steps to find the inverse. Okay, on this slide there are 4 problems. So, in these 4 problems, I'd like you to write the inverse of them, and then I want you to check it with using x equals 5 and 12 as an example. Now, for the first 2, go ahead and just write the inverse of the function by using the inverse operation method. What we did in 2 slides ago. Now, for here, I want you to do these 2 using the method I just showed you on the last slide, using the 4 steps. Alright, so go ahead and pause the video, and we'll do these 4 problems. Alright, now that you've worked through each of these, let's check our answers. So, let me uncover these answers here, and I want you to check them with what you have. Okay, so looking at each of these, hopefully your answers match up. If they don't match up, I want you to go back, watch that video piece again, try them again until you can get it. Make sure you can do the 4 steps here. Okay, on 4 and 5, make sure you can do the 4 steps. Alright, now, here's what I want us to do. We're going to put a little Easter egg in here. We're going to take a thumb quiz. So I want you to send me an email, cliffordfrench@usd475.org. And if you are a thumbs up, just send me an email in the title field that just says thumbs up. And that way I know you're ready and you're good to go on this quiz. If you're a thumbs middle or a thumbs down, then I want you to tell me that as well. But that tells me something. If you're still a thumbs down or a thumbs middle, I want you to go back and do this video again until you feel more comfortable with it. And if you still don't feel comfortable with it, I want you to come in for help tomorrow morning. Get some assistance prior to taking this quiz. So, send me an email, and you know what? It just may be worth a point or 2 on the quiz. Yes, quiz extra credit, not homework extra credit. Quiz extra credit. Okay, so give me your best effort. Okay, folks, that's going to wrap it up for today. So, next class period, what do we have? Yes, a quiz. So, come to class prepared, ready to go. Make sure you sent me that email so you get that 1 or 2 extra credit points on the quiz. All right, well, I will say so long, farewell, and we'll see you next class.